For generations, humanity has searched the sky for meaning. We built observatories, created equations, and developed theories to explain where we came from and how the universe works. Yet every new instrument we create seems to reveal something even more mysterious. Now, the observations coming from the James Webb Space Telescope are forcing scientists to ask difficult questions, because some of what it sees does not fit comfortably within our current understanding of the cosmos. The telescope has captured deep views of distant space unlike anything seen before. Hidden inside those images are galaxies, structures, and patterns that appear far more organized and mature than expected. Instead of a young chaotic universe slowly taking shape, Webb has revealed systems that seem surprisingly developed. In certain observations, astronomers noticed repeating arrangements and unusual alignments spread across enormous distances. Some formations appear remarkably structured, creating debate about whether these are statistical coincidences or signs that larger cosmic processes are at work. The deeper the telescope looks, the more complex the picture becomes. One object attracting major attention is the exoplanet HIP 65426b. This world is enormous, several times more massive than Jupiter, orbiting very far from its host star. Its existence challenges traditional models because planets of this size are difficult to explain in such positions, especially around relatively young stars. Researchers continue investigating how such a massive planet formed and survived in its current orbit. Some suggest unknown formation mechanisms, while others believe planetary evolution may be more diverse than previously imagined. Whatever the answer is, the discovery shows that nature often creates worlds beyond our expectations. Webb also captured extraordinary gravitational lensing events known as Einstein rays. These occur when light from a distant galaxy bends around a massive foreground object, producing circular patterns of light. Some of these rings appear incredibly precise and symmetrical. While gravitational lensing itself is well understood, the level of alignment required remains astonishing. It reminds us that the universe operates with an elegance that often feels almost mathematical. Perhaps the most surprising discoveries involve ancient galaxies seen at the edge of observable time. According to earlier models, the first galaxies should have been small, irregular, and still developing. Instead, Webb has observed galaxies that already appear bright, massive, and unexpectedly evolved. These systems seem to exist far earlier than many cosmologists anticipated. Their maturity suggests that galaxy formation may have happened faster than predicted, or that important pieces of the story are still missing. This does not necessarily overturn cosmology, but it does force scientists to reconsider assumptions about the early universe and the speed at which structure emerged after cosmic beginnings. In other observations, astronomers detected gravitational effects in regions where visible matter appears absent. Light bends and distorts as though hidden mass exists, despite no obvious stars or galaxies being present. Most researchers connect these effects to dark matter, the mysterious substance believed to make up much of the universe's mass. Yet dark matter remains invisible and poorly understood. Because of that uncertainty, every unusual observation raises new possibilities. Could unseen structures exist beyond current models? Could hidden distributions of matter shape the cosmos in ways we have not yet recognized? Large-scale cosmic filaments have also drawn attention. These enormous structures stretch across vast distances, connecting clusters of galaxies into what scientists call the cosmic web. Some newly studied regions show striking organization and repeating distributions. Although mainstream cosmology explains these patterns through gravity and evolution over billions of years, their scale and symmetry continue to fascinate researchers. Human minds naturally search for order, so caution is important. Still, the sheer complexity of the cosmic web leaves open questions about how structure emerges on the largest scales imaginable. Another idea gaining interest explores whether dark matter might influence cosmic history more deeply than expected. Some theorists wonder whether invisible matter could preserve information through gravitational interactions, subtly shaping future structures. This remains speculative, but it highlights an important truth. Modern astronomy is entering territory where observation often arrives before explanation. Then there are reports of unusual light fluctuations observed during deep field studies. Faint repeating signals occasionally appear in astronomical data and are usually traced to natural causes, instrumentation effects, or processing artifacts. So far, no confirmed evidence links such observations to artificial origins. Scientists remain cautious because extraordinary claims require extraordinary proof. Still, unexplained signals capture attention because they remind us how much remains unknown. Every mystery invites investigation. The James Webb Space Telescope was designed to study the distant past, allowing humanity to look back toward the earliest eras of cosmic history. Yet in doing so, it has also revealed how incomplete our understanding still is. Unexpected galaxies, giant planets, hidden mass distributions, enormous structures, and unanswered questions all point toward the same conclusion. The universe is more complicated than we imagined. Maybe these discoveries will eventually fit into existing theories. Maybe they will lead to entirely new ones. But one thing is already clear. The deeper we look into space, the less ordinary the universe appears. Perhaps these observations are simply natural phenomena waiting to be understood. Or perhaps they are hints that reality is larger, older, and more intricate than humanity ever expected. Whatever the answer may be, the search has only begun, and every new image brings us one step closer to understanding the cosmos and our place within it. Far beyond the reach of ordinary observation, where ancient light travels for billions of years before touching our instruments, the James Webb Space Telescope continues to uncover a universe that feels increasingly unfamiliar. Every new observation adds another piece to a puzzle that appears larger than anyone expected. One of the greatest mysteries emerging from Webb's discoveries involves the earliest era of cosmic history. Astronomers once believed the first stars formed slowly, gradually illuminating a dark universe after the cosmic dawn. But Webb's images suggest that this transformation may have happened much faster. Some distant galaxies already appear bright, chemically enriched, and surprisingly organized. That means generations of stars may have formed, lived, and died far earlier than expected. If true, the young universe was evolving at extraordinary speed. Researchers are now re-examining models of star formation, trying to understand how these ancient systems became so developed in such a short time. Then came another surprise. Webb detected massive reservoirs of dust in galaxies that should have been too young to produce them. Cosmic dust is not ordinary dust. It forms through stellar processes, often after stars complete their life cycles. Large amounts of dust usually imply time, evolution, and repeated generations of stars. Yet Webb found these signatures in places where time should have been limited. This raises difficult questions. Did stars form faster? Were early galaxies more efficient? Or are there mechanisms from the infant universe that science has not yet fully identified? Meanwhile, the telescope's infrared instruments revealed hidden structures inside star-forming regions once blocked from view. Dense clouds that appeared silent suddenly became crowded landscapes filled with newborn stars, disks of material, and energetic activity. Entire regions once thought empty turned out to be alive with formation processes. These discoveries are changing how astronomers understand stellar birth. Instead of isolated events, star formation may be more interconnected and dynamic than previously imagined. Webb has also provided unprecedented views of exoplanet atmospheres. For the first time, scientists can study chemical fingerprints in extraordinary detail, identifying gases and environmental conditions around distant worlds. Water vapor, carbon compounds, atmospheric layers, and temperature variations have already been observed.